Hello everyone. Here we are going to discuss the important topic that is genetic inheritance of single gene disorders. I will be discussing 4 inheritance, that is autosomal dominant, autosomal recessive, X-linked dominant and X-linked recessive. I will tell you the features of each of these inheritance, the pedigree analysis along with examples. I will tell you the examples with super simple mnemonics. So let's start it. So let's start the topic, that is genetic inheritance of single gene disorders, autosomal dominant, autosomal recessive, X-linked dominant and X-linked recessive. So this is the overview. So first I will let you know the normal human karyotype. Then I will tell you the 4 type of inheritance, autosomal dominant, autosomal recessive, X-linked dominant, X-linked recessive. We will be discussing the features of each of them, the pedigree analysis of each of them and examples of each of them. So I suggest you, this table is given. So I suggest you to make this table in your notebook, or if you have the hard copy of the book, you can fill in that. So please fill this table by yourself. Autosomal dominant, autosomal recessive, X-linked dominant, X-linked recessive. Now please write the features of each of them, draw the pedigree analysis of each of them and write the mnemonics for the examples of each of them. So if you get a long question on this, you have to write all 4. And if you get a short question, you will get question on any one of them, either autosomal dominant or recessive or X-linked dominant or recessive. So you have to write that particular column in your exam if it is short or very short question. So let's start it. Let's start with the normal human karyotype. Now, how many chromosomes are there in human cell? So this is the human cell. This is the nucleus of the human cell. In the nucleus of the human cell, there are total 46 chromosomes. Instead of saying 46 chromosomes, try to say 23 pairs of chromosomes. So this is pair number 1, pair number 2, pair number 3, pair number 4, pair number 5. Likewise, there are total 23 pairs of chromosomes. Got it? So in human, there are total 46 chromosomes. There are 23 pairs. So you can see the 23 pairs are drawn in front of you. You can count total 23 pairs are there. Total 46 chromosomes are there. So out of the 23 pairs, the 22 pairs, the first 22 pairs are same in everyone. The first 22 pairs are same in everyone. So this is known as autosomes. These are known as autosomes. The last pair, you can see the 23rd pair. The last pair is different in male and in female. So this one is known as sex chromosome. It determines the gender of the individual. We all know in males it's XY and in females it's XX. So in females it's XX, in males it's XY. The last pair differ in male and female depending on the gender of the person. But first 22 pairs is common in everyone, whether the person is male or female, it is common in everyone. So this is the normal karyotype. I hope you understood. Now let's start the 4 type of genetic inheritance. So autosomal dominant, autosomal recessive, X-linked dominant, X-linked recessive. Before that, to understand the pedigree analysis of each of them, you must know the normal pedigree signs. I hope you know that. If you don't know the normal pedigree symbols, let me help you with that. So the male, healthy male is represented by a square. Can you see the square? Empty square. The healthy female is represented by a circle. It is conventional. You have to learn this. And the affected male and female, if the male and female have the disease, they are affected. They are still represented by the square and the circle. The male with a square, the female with a circle. But this time they are filled with black color. They are not empty. If they are healthy, they are empty. If they are affected with a disease, they are filled with black color. You can see. And if they are carrier, so half filled, half empty, the male and the female. The carrier in case of autosomal dominant or autosomal recessive. But if they are carrier in case of X-linked diseases, there is a dot at the center. The dot at the center. So if they are empty, the male and the female, it means they are healthy. The male is a square and the female is circle. And if they are affected, they are filled with black color. The male is filled. The square is filled with black color and the circle is filled with black color. And if they are carrier, they are half filled, half empty, like this. So male is square, half filled, half empty, and the female is a circle, half filled, half empty. They represent they are the carrier. Here they are affected by a disease. Here they are representing they are the carrier. So these are the normal symbols. I hope you got it. So let's start with the first one, autosomal dominant. So I will tell you the features, pedigree and examples. So let's start with the features. You can see the features with the pedigree. So autosomal dominant diseases. All autosomal dominant diseases can present in heterozygous state also. What do you mean by heterozygous state? So these are the 2 chromosomes. You can see a pair of chromosomes. So one of the chromosome is affected. One of the gene is affected. This is a pair of allele. So one of the gene is affected, another is not affected. This is heterozygous state. So phenotypically the person will express. So the autosomal dominant diseases can express in heterozygous condition also. It is not necessary in contrast to autosomal recessive disease. They express only in homozygous state. These are the diseases they can express in homozygous state also as well as heterozygous state also. So they can be able to present in heterozygous state, which differentiated from the autosomal recessive disease. Onset is variable. Sometimes they start in childhood, sometime in young age, sometime in old age. Onset is very variable. There is no generation gap. You can see the first generation, there is an individual. You can see the second generation, you can see the third generation. In all generation, there is affected individual. There is no generation gap. There is no generation skip. In contrast to autosomal recessive, where I will tell you generation skip is quite possible. And there is no gender bias. Gender bias is not there. You can see the affected male when marries a female, the male is transmitting the disease to the sons as well as daughter. And the affected female, when the female is affected, she also transmits the disease to son and daughter. So there is no gender bias. The affected male when marries a normal female, or an affected female when marries a normal male, both of them are transmitting the disease to their sons and daughters equally. So there is no gender bias. By the way, in autosomal dominant and autosomal recessive, there is no gender bias. They will transmit the disease equally in the sons and daughter. But here, there will be gender bias. I will be telling you. So here there will be no gender bias. Here there will be gender bias in X-linked dominant and X-linked recessive, because here sex chromosomes are involved, right? So I guess this is the basics and everyone knows that. If you don't know, please learn. Learn. This one is expressing in the heterozygous condition. Onset is variable. Generation skip is not there. Gender bias is not there. We will do all opposite. Most of the things opposite in autosomal recessive. And this is the pedigree in front of you. In this pedigree, what is visible? We can see in every generation, there is the individual. Now, in the first generation, see, the male is affected. The husband is affected, having the disease, and the female is normal. The wife is normal. So the husband has the disease, the wife is normal. So whenever they are conceiving, out of the 4 children, 1 son and 1 daughter is affected. So they are equally transmitting the disease to their children. Now, one of the daughter is marrying a normal male. One of the affected daughter marrying a normal male. So again, the disease is transmitted to equally male and female. And one of the son is marrying a normal female, one of the affected son. So again, they are transmitting the disease equally, more or less equally. So we have seen there is no generation gap, there is no gender bias, onset is variable, and they express in heterozygous conditions. So these are the features. This is the pedigree coming on the examples. For examples, learn the mnemonic. I'm having a mnemonic for you. These are all the diseases, the list of disease in front of you. They all show autosomal dominant inheritance. Okay, so the mnemonic is वो familial hypercholesteremia autosomal dominant है. That is the mnemonic. वो V stand for von Willebrand disease. Familial stand for familial adenomatous polyposis. Hypercholesteremia stands for hypercholesteremia only. Autosomal depends. A stands for adult polycystic kidney. Dominant. D stands for dystrophic myotonica. O stands for osteogenesis imperfecta. M stands for Marfan syndrome. I stand for intermittent porphyria. N stand for neurofibromatosis 1. A stand for achondroplasia. One more N stand for neurofibromatosis 2. So both the neurofibromatosis are there, 1 as well as 2. T stand for tuberous sclerosis, and H stand for 2 things, Huntington's disease and hereditary spherocytosis. So in your exam, you can get a short or a very short question that write 5 example, write 6 example, write 4 example of autosomal dominant. So you can write any of them. Or else in your university exams only, you can get MCQs on that. Which of the following show autosomal dominant inheritance? Or they will give you a name of disease. Marfan syndrome shows which inheritance? So out of the 4 options, you have to pick autosomal dominant. So this list will be helpful in multiple purpose, for short question, for very short question, for MCQs. You have to learn this mnemonic. What is the mnemonic? Can we say it once? वो familial hypercholesteremia autosomal dominant 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 है. Can we try to say the full form together? Please try it now. V for von Willebrand disease. F for familial adenomatous polyposis. H is for Huntington syndrome. H is hypercholesteremia here. Here one more H is Huntington syndrome. One H is hypercholesteremia. A is adult polycystic kidney disease. D is dystrophic myotonica. O is osteogenesis imperfecta. M is Marfan syndrome. I is intermittent porphyria. There are 2 N. So one N is neurofibromatosis 1, one N is neurofibromatosis 2. A is achondroplasia and T is tuberous sclerosis. So I tried my best to help you to learn that. So with the help of the mnemonic, at least you can enumerate the examples. So we are done with the first one, autosomal dominant. Can we revise? What are the features? See ma'am, 4 features are there. It can express itself in heterozygous condition also, number 1. Number 2, onset is variable. Onset is variable. Generation gap? No generation gap. And what about the gender bias? There is no gender bias. No generation skip, no gender bias. So it is present in all the generation, first, second, third, and equally transmitted in the sons and daughter. So that is the features. Okay, pedigree, you can draw it. You have to draw the pedigree here. You have to draw the pedigree. So how to draw the pedigree? So in the pedigree, you have to show one male, one female. You can affect anyone. It's your choice. Either take affected male or affected female. Doesn't matter here. So just suppose I am taking an affected male and a healthy female. One of them is affected. They are marrying together. Okay. So they have the siblings. They have the siblings. Just suppose they have 4 siblings. 2 of them are son and 2 of them are daughter. So out of the son and daughter, 50% of the sons are affected and 50% daughters are affected. It is equally transmitted in males and females. Now their son and daughter who are affected, they are marrying a normal individual. And again, they have the siblings. They have the siblings and that will be the same again. So here also 2 sons, out of 2 sons, 2 daughters, one is affected, one is unaffected. Here also out of 2 sons and 2 daughters, one is affected and one is unaffected. So basically, I want to show you here 2 things. What 2 things? Number 1, in all generations, there is affected individual. There is no generation gap, no generation skip, and there is no gender bias. You can see the male can transmit disease to daughter and son both, and the female can also transmit the disease to daughter and son both. We have proven that with the help of pedigree. So rather than saying prove it in the form of the pedigree, draw the pedigree and say the examples. For examples, very easy. You have the mnemonic with you. वो familial hypercholesteremia autosomal dominant, DOMINANT, dominant है. So say the full form. We are done. Now coming on the next one, autosomal recessive. Autosomal recessive. So see the features, see the pedigree, see the examples. The same thing. So autosomal recessive expressed only in homozygous condition. So this is the pair of gene, the allele we can see. If both of them are affected, then only it will express. If it is homozygous. If it is heterozygous, now, I mean, one of the gene is affected, one is not affected, they will not express. They will not express. So they will not express in heterozygous condition. They will express only in homozygous condition, in contrast to autosomal dominant. Onset is uniform. It occurs usually in childhood. In contrast to autosomal dominant, where the onset was variable. It can occur anywhere. But here it can occur only in childhood. Here generation skip is seen. You can see in the first generation, there is an affected individual. In the second generation, no one is affected. In the third generation, no one is affected. Again, in the fourth generation, the individuals are affected. So generation skip is common. In contrast to autosomal dominant, where no generation skip was there. And what about the gender bias? There is no gender bias. We can prove that. See, the affected female, the female is affected, marries a normal male. Marries a normal male. You can see all the 4 siblings are normal. They don't have the disease. I mean, maybe because it is expressed in heterozygous condition. So they are not expressing. So here also they are not expressing. And here in this, you can see they are expressing. So gender bias is not there. Gender bias is not there. So these are the features. These are the features. So in contrast to here you can write autosomal dominant was expressed only in heterozygous condition, heterozygous as well as homozygous. This one expressed only in homozygous, not in heterozygous. Okay, here the onset was variable. Here the onset occurs in early childhood. Here generation skip is not there. Here generation skip is there. But one thing is common. Gender bias is not there in both of them. There is no gender bias neither in autosomal dominant nor in autosomal recessive. Now you can draw the pedigree also here. Now let me tell you the examples. What are the examples here? There is a mnemonic. The mnemonic is ABCD, EFGH, SPW. That is a mnemonic. A stand for albinism and alpha-1 antitrypsin deficiency. So 2A are there. Albinism, alpha-1 antitrypsin deficiency. B for beta thalassemia. Along with beta thalassemia, we have sickle cell anemia also. So you can learn that also together. C for cystic fibrosis. Okay. D for deafness, sensory neural deafness and Dubin-Johnson. We have 2D. E for enzyme deficiency, especially G6PD deficiency or glycogen storage diseases, lysosomal storage diseases. F for 2F are there, Friedreich ataxia and Fanconi anemia. G for galactosemia. H, again 2H are there, Hurler and hemochromatosis. So we have 2H, we have 2F, we have 2A, you can see. We have 2D. Okay, likewise. S is sickle cell anemia, P is phenylketonuria, and W is Wilson. So can we try to say it? So say the mnemonic. The first thing you have to say the mnemonic. It's A, B, C, D, E, F, G, H, S, P, W. So we have 2A, we have 2D, we have 2F also, we have 2H also. Try to say maximum as many as you can memorize. You can get a short question or a very short question, write 5 examples, write 10 examples. So you should be able to enumerate them. Okay. So in A, we have albinism as well as alpha-1 antitrypsin deficiency. B is beta thalassemia. C is cystic fibrosis. D is Dubin-Johnson. One is Dubin-Johnson, one is deafness, sensory neural deafness. E is enzyme deficiency like lysosomal enzyme deficiencies. Okay, lysosomal enzyme deficiencies. F is 2F Fanconi anemia and Friedreich ataxia. G is galactosemia. H, again we have 2H, Hurler disease and hemochromatosis. S is sickle cell anemia. P is phenylketonuria and W is Wilson. So that is how you have to write the mnemonic and try them. So we are done with the examples also. So try to write down the features of this, both of them. We will write in the end, draw the pedigree of both of them and write the mnemonic of the examples of both of them. So here the mnemonic was वो familial hypercholesteremia autosomal dominant DOMINANT है. That was the mnemonic. And here the mnemonic is A, B, C, D, E, F, G, H, S, P, W. So say the full form again and again. Okay, coming on the next one. The next one is X-linked dominant. Let's start X-linked dominant. So what are the features here? So here the gender bias is there. You have to understand the gender bias. See. Very interesting. Everyone see. So here the mother is affected. See, the female is affected, but the male is normal. Can you see the mother is affected, but the father is normal? So a diseased mother marries a normal father. I mean the diseased female marries a healthy male. So they have the siblings. They have 4 siblings, 2 daughters and 2 sons, for example. So out of the 2 daughters, you can see 4 siblings. 1, 2, 3, 4. See the 2 circles. One is affected, one is not affected. And see the 2 sons. One is affected, one is not affected. So basically, when the female is affected, she is transmitting the disease to 50% son and 50% daughter. She is giving to 50% sons and 50. When the mother is affected, she is giving the disease. Mother is, impartial. She loves all the children equally. So when she is affected, she is giving her gene to 50% son, 50% daughters. But what about the father? What about when we take the reverse? When the father is affected? See here, the father is affected. Can you see here? The father is affected. The father is marrying, the male is affected. The male is marrying a normal female. Again, they have the 4 siblings. Let me show you the 4 siblings here. They have 2 daughters and they have 2 sons. So father is very partial. Father loves son. Father is giving disease to 100% daughters. Both the daughters are affected, but none of the son is affected. None of the son is affected. Got it? So when the male is affected, the disease is transmitted to 100% daughters and none of the son. So I will prove it rather than learning and showing in the pedigree. Understand it. So you can see the 2 scenarios. See, everyone on the screen. So what you can see here, you can see this is the male XY and this is the female. So here the male is affected. The female is normal. You can see XX. You can see, but the male XY. So X chromosome is affected. So the male is affected. When an affected male marries a normal female, what is happening? You tell me. And here the male is normal. You can see the second scenario. The male is normal. See the second scenario. The male is normal, but marrying an affected female. Here the female is affected. Here the female partner is affected when they are marrying. So when an affected male marries a normal female, what is the scenario? And when a normal male marries an affected female, what is the scenario? You see, you separate the gametes and do the fusion. You do the fusion, you will get the results. Can we do the fusion? So here you can see it will be like this. You all can understand how we do the fusion. So this is how we do the fusion. So we have 4 siblings here. What are the 4 siblings here? So basically here the male is affected. Now the affected gene of the male is going to daughters only. The affected gene is going to daughters only. And you can see both the sons are healthy. Both the sons are healthy. So the affected male, that is father, is giving disease to 100% daughters. 100% daughters are affected and 100% sons are healthy. 100% sons are healthy. So the father is giving disease only to daughters. Father don't love daughters. No, just a mnemonic I'm telling you. It's not the fact. Hana? Father loves daughter more rather. Okay. But here just a mnemonic you can learn like fathers is not loving the daughters. Father is giving the disease to 100% daughters. Father is not giving the disease to the son. But what about the mother? When the mother is affected, what is happening? See the gametes. Now do the fusion. Can we do the fusion? So do the fusion like this, like this, like this, and like this. You can do the fusion like this. Now see what are the things are there. So here you can see it will be like X like this. Here you can see it's like this. Here XX and here XY. You can see. So when the mother is affected, out of the 2 daughters, one is affected, one is not affected. Out of the 2 sons, one is affected, one is not affected. So 50% sons are affected and 50% daughters. So mother is impartial. You can learn. So learn the summary. You don't have time to draw all these. You have to learn the summary. So you should be able to draw the pedigree. So what is the summary? In X-linked dominant disorders, the affected male gives the disease to 100% daughters, none of the son. But when the female is affected, she is transmitting the disease to 50% son and 50% daughter. This is the summary. Learn the summary, write it in the features, and draw the pedigree. In the pedigree, you should be able to start like this. So affect one of them. It's your choice. You can affect any one of them. For example, I am taking a mother. I'm taking a mother who is affected. So they marry together and they have 4 siblings. Out of the 4 siblings, mother is giving. So 2 are daughters and 2 are son. So she is the mother now. She will transmit the disease to 50% daughter, 50% son. So out of the 2 daughters, 1 is affected, 1 is healthy. Out of the 2 sons, 1 is affected, 1 is healthy. Now this son, this is the son who is marrying with a normal female, Again, they will also have 4 siblings. 1, 2, 3, 4. Now this time the male is affected. So again, there are 2 daughters and 2 sons, but male is partial now. Male is transmitting the disease to 100% daughters. Both the daughters are affected and none of the son is affected. So you have to show it in the pedigree. I hope you all got it. You have to show this in the pedigree. So when a affected female marries a normal male, 50% daughter, 50% sons are affected. It's visible. And when a affected male marries a healthy female, all the daughters, 100% daughters are affected and none of the son is affected. It's visible. It's X-linked dominant inheritance. Please learn it. It's X-linked dominant inheritance. I hope you got it, Hannah. I hope you got it. So you have to write it. You have to draw it in the pedigree. Better to draw. Now tell me the examples. There are 4 examples. The mnemonic is FAIR, F-A-I-R. S stand for facio-oral syndrome. A stand for Alport syndrome. I stand for incontinenta pigmentosa. And R stand for resistant rickets. So please learn the 4 examples. So we are done with this and this, and finally I'm coming on the last one, X-linked recessive. So let's start X-linked recessive. So here you can see X-linked recessive. What is the genotype of male? Male is XY. And what is the genotype of female? It's XX. This one is male, this one is female. So we are studying X-linked recessive. So this gene is defective. X gene is defective, but it is recessive. This one is recessive. So let me write small d here to express its recessive involvement. Okay, you can write like this. This is recessive. So I mean to say in males only one X is there. There is not another X to suppress it. So males are always cases here. But in female there are 2 X now, and recessive disease don't express in heterozygous condition. They express only in homozygous condition. So 1 X is affected but 1 X is normal. So it is a heterozygous condition. So female will not present. Female will always be a carrier. Female will always be a carrier. So my point is that in X-linked recessive diseases, the males are the cases and females are the carrier. Because in females, there is heterozygous presentation. Recessive disease don't present in heterozygous, I told you. The female will present in only case if both the genes are affected. In homozygous. In heterozygous condition, they don't present. Okay, so we will take 2 scenarios. What are the 2 scenarios? You tell me. You tell me what are the 2 scenarios. Here, you can see the male is affected. The male is affected, you can see. The male is a case, but female is healthy. The female is healthy and they are marrying together. So there is a diseased male who is marrying a healthy female. They marry together. They marry together. They have the 4 siblings. We will see what is the scenario here. Here the male is healthy. We will do the reverse. But what is the female? Female is a case. No, female is a carrier. Female is a carrier. So this female is a carrier. So affected male marries a healthy female. See what is happening? Or a healthy male marries a carrier female. Don't say affected female. Here females are not affected. So affected female is not possible. Okay. So affected female can be very rare if both of the genes are involved. It's rare of the rarest. Okay. But here females are carrier. So tell me what will happen. You can see the gametes we have separated. Now do the fusion. Can we do the fusion? Do the fusion like this, like this, like this, like this. So tell me the 4 siblings which are formed here. Tell me the 4 siblings which are formed here. So you can see the affected father is transmitting the disease again to daughters, not the son. So it is transmitting the disease to daughters. So both the daughters will be carrier, both the sons will be normal. So here this couple will have 4 children. For example, they have 4 children. 2 daughters, both of them are carrier. And both sons, both of them are healthy. Normal, healthy. The sons are normal. So again, father is doing the partiality. Father is transmitting the disease to the daughters, not to the son. So 100% daughters, but they are not cases. In contrast to X-linked dominant. Here the females are carrier, the daughters are carrier. In contrast to X-linked dominant where the females were the cases. Here females are carrier. Now do the reverse. Again the same scenario are there. Do the reverse. Now here you can see the 4 siblings are like this. You can make out the 4 siblings. Okay, if you wish. You don't have to draw all these. It is just for your understanding so that you can draw the pedigree well. So what we are drawing here, what the affected female is doing, she is having 4 children. XX, XY, XX, XY. And she is transmitting the disease equally. Out of the two female, two daughters, one is affected, one is not. Out of the two sons, one is affected, one is not. Got my point? So out of the 100% son, 50% are cases, 50% are healthy. Out of 100% daughters, 50 are carrier and 50% are healthy. So that is the thing. So same is shown to you here. So you can see this is the couple, the first couple. Who is affected? The male partner is affected, the female is healthy. So male is affected. They are marrying together. They have 4 siblings. So say where are the 4 siblings? 1, 2, 3, 4. Both the sons are normal and both the daughters are carrier. Because the father is giving disease only to the daughters, not to the son. Now one of the daughter who is carrier, marrying, she is married to a healthy male. So here take the second possibility. Here the daughter, the female partner is carrier, male is healthy. So again they have the 4 siblings. So out of 2 daughters, one is carrier, one is healthy, and out of 2 sons, one is carrier, one is the affected male, and one is healthy. So mother is giving the disease to 50% daughters, 50% son. I hope you all got it. So this is the pedigree you have to draw. So please draw the pedigree, write down the features. I hope you all got it, right? So how to draw the pedigree? Start with a couple, male, female. You can start with anyone. For example, I am starting with the male affected. The male is affected. I am telling you the pedigree of X-linked recessive. Female cannot be affected. Female can always be a carrier. So I'm starting with male and female. The male is affected. They are marrying together. Once they marry together, they will have 4 siblings. This is how I draw. They have the 4 siblings. So 2 are daughters and 2 are sons. Okay. So 2 are daughters and 2 are sons. So the father transmits the disease only to the daughters. So both the daughters will be carrier. And both the sons are healthy. You can see. So father is transmitting the disease only to the daughters. Both the daughters are carrier and both the sons are normal. They are healthy. So father is doing the partiality. Now one of the daughter, take one of the daughter. One of the daughter is marrying a male who is healthy. They do the marriage. Again, they will have the 4 siblings. Now the scenario is reverse. This time we are taking the female partner is affected, not the male partner. The female partner, but the female partner is carrier. Again, they have 4 siblings, 2 daughters, 2 sons. But mother is impartial. Mother will give out of the 2 sons, one is affected, one is healthy. You can see out of the 2 sons, one is affected, one is healthy. And out of the 2 daughters, one is carrier, one is healthy. So mother is giving 50% disease to the daughters and 50% disease to the sons. So this is the pedigree of X-linked recessive. You should be able to draw it whatever you are saying. So this is the thing. And come on, the examples finally. The example is Graham Bell, Grahambell. G stand for G6PD deficiency. R stand for retinitis pigmentosa. A stand for androgen insensitivity. H stand for 2 things. Hemophilia. You get a question on hemophilia. Okay. And hydrocephalus. A stand for adrenoleukodystrophy. M stand for Meniere's disease. B for 2 things. Baker and Duchenne muscular dystrophy and blindness. It's color blindness. B for color blindness. E for Emery-Dreifuss dystrophy. There are 2 L. One is Lowe disease, one is Leishman syndrome. So try to say the full form Graham Bell. So we are done with all 4. So we are done with the genetic inheritance of single gene disorder. Right. So there are 4 inheritance. Autosomal dominant, autosomal recessive, X-linked dominant, X-linked recessive. So can you tell me the features of all 4 quickly? So autosomal dominant expressed in heterozygous condition. They can express in heterozygous also, but recessive express only in homozygous. Here the onset is variable. Here onset is in childhood. Here generation gap is not there. Here generation gap is there. What about the gender bias? Gender bias, here there is no gender bias. Here also there is no gender bias. So here one feature is common. Okay, and you can draw the pedigree to show whatever we are saying. What about X-linked dominant and X-linked recessive? Here affected male give the disease only to 100% daughters, not to the son. But the affected female give the disease to 50% daughters and 50% son. You should be able to draw it in the pedigree rather than learning. What about the X-linked recessive? Here males are cases and females are carrier. Females are not cases. And the scenario is same like this. But the only difference, the females are carrier. Tell me the examples. I mean the mnemonics. So autosomal dominant, you can see the pedigree of all 4. Okay, so this is a pedigree of autosomal dominant. This is a pedigree of autosomal recessive. This is a pedigree of X-linked dominant. This is a pedigree of X-linked recessive. So here in autosomal dominant, appreciate there is no generation gap. First generation, second generation, third generation. And all the generation affected individuals are there. And the gender bias is not there. The male is transmitting the disease equally to female, to sons and daughters. And the female is also transmitting the disease equally to sons and daughters. What about the autosomal recessive? You can see first generation is affected. Second is not affected, third is not affected. Again, randomly, fourth is affected. So generation gap is there. in contrast to autosomal dominant. Okay, number one. And number two, here also gender bias is not there. The affected female can transmit the disease to both, the affected male can transmit disease to both. So gender bias is not a feature. It's not there neither in autosomal dominant nor in autosomal recessive. Now come in X-linked dominant and X-linked recessive. See, now in X-linked dominant, the female, the mother, is giving the disease to 50% son, 50% daughter. But the father is giving the disease to 100% daughters, none of the son. The same we can see here in X-linked recessive also. Here also, father is giving the disease to 100% daughter, but here the 100% daughters were the cases. Here 100% daughters are carrier. That is the only difference. And the mother is giving the disease to 50% sons, 50% daughter. The only disease difference is there. Here, it's the females are the carriers. So understand the pedigree rather than learning and write in your own words. I hope you all got it and learn the 4 examples. The 4 examples are in front of you. So this is the list of autosomal dominant. You can see the mnemonic. This is the list for autosomal recessive. See the mnemonic. The list of X-linked dominant, see the mnemonic. The list of X-linked recessive, see the mnemonic. So for autosomal dominant, the mnemonic is वो familial hypercholesteremia autosomal DOMINANT dominant है. See the full form. For autosomal recessive, the mnemonic is ABCD, EFGH, SPW. ABCD, EFGH, SPW. Learn the full form. For X-linked dominant, the mnemonic is FAIR, FAIR. Learn the full form. And for X-linked recessive, the mnemonic is Graham Bell, GRAHAMBELL. You get short or very short question that write 4 examples or 5 examples of autosomal dominant, autosomal recessive, X-linked dominant, X-linked recessive. So you should be able to enumerate. Or else you will get MCQs on that. So that which of the following show autosomal dominant inheritance, autosomal recessive likewise. So I guess we are done. You should be able to fill this table and have a look on all long question, short question, very short question and MCQs of this topic particularly given in the notes section and question bank section. Thank you so much.